All right. So you'll see up at the top, we multiplied them a little bit on Friday. We were actually adding, subtracting, and multiplying on Friday. That's what we were doing with our radicals. So today, the last kind of missing element there is the division of radicals. So there's two different things that could happen. The easy way, if you kind of look at this one here, would be if both of these end up being perfect squares. So like the square root of 36, we know to be 6. So we can just write that down. And then the square root of 25, we know to be 5. And that's pretty much it. All right, so if they're both perfect squares, then you're just going to do what you kind of normally would. If I wanted a decimal, you throw it into your calculator. If you want to leave it as a fraction, you just leave it as a 6/5. One other thing, just so we are aware, let's say at some point I gave you like, what would work good, 64 divided by 49. As long as the square root symbol is over both the numerator and the denominator, it just means both of them are going to be taken the square root of. So if you ever see something like that, the numerator and the denominator, we take that to both, you're going to get 8/7. Okay, if we ever see that. Now, where this becomes a little bit more involved is if I now do this to where the numerator is good, the square root of 36 we know, that's 6. But the square root of 50 is not one of those perfect squares that we have listed in the previous couple of days of notes. So all we can really do with this is simplify this. So this is kind of what we've been doing the last few days, where the square root of 50, the 25 is a perfect square. And if we multiply that by 2, that's going to give us our 50. So again, the numerator, just a 6. We're going to rewrite that. That square root of 25, we know to be a 5, so you're going to change that to be a 5. And then a root 2, you can't do anything with. So when we have this problem, all right, where we have what we're calling a radical, a square root in our denominator, if I want you to take a square root or a radical in simplified form, no radical can be in our denominator. So if you look at this problem right here, we very clearly have a radical in our denominator. We don't want that. The reason for that, big picture wise, if you did the square root of 2 into your calculator, so at some point you would have learned rational and irrational numbers. Square roots that aren't perfect squares are irrational. This is going to, if you threw that into your calculator, it gives you 1.414. And then this is a decimal that goes on forever and ever and ever. It doesn't repeat. That's why it's called irrational. So think about if we were to divide, let's say I gave you 64 and I wanted you to divide by 2, good old fashioned, middle school math. I can do this because I can say, all right, how many times does 2 go into 6? And it would be a 3. And if you remember kind of your long division, those cancel. And then how many times does 2 go into 4? It's a 2. So 64 divided by 2 is 32. Our issue with this guy, it is impossible for me to take 64 and divide it by a number that never ends. It's not a finite number. There's no way I can take a non-terminating number and try to divide that into a 6. So dividing by an irrational number, which is what radicals are, that is impossible. So we never want to leave an irrational number or a square root in our denominator. All right, so here's how we then combat that. All right, so if we go to this problem here, a couple things real quick. It's similar to if I gave you the square root of 2 times the square root of, I'll make it easy, 3. As long as they are both underneath a square root, we can go ahead and multiply those and get a 6. So it's the same thing here. If we look at these two numbers, these are both underneath square roots. So as long as they are both underneath square roots, if we can divide them, just simply divide them. So a 70 divided by 7 is still 10. We're not changing the rules on regular old division. But since they are both underneath square roots, you're going to leave it underneath a square root. When we do that, our denominator right now is a 1, so that's perfectly fine. What we are trying to avoid, and we'll get to those in a minute, is when we have a square root in our denominator. But right now, that's all you're doing. 70 divided by 7 is 10, and then they're both underneath the radical, so we leave the 10 underneath the radical. All right, so same thing here. As long as they are both underneath, all we have to do is rewrite that radical. We can do 28 divided by 7, leave it as a 4. Now over here, you can't do anything with the root 10. That doesn't simplify, so we just left it as a root 10. But the square root of 4, we definitely can. so that we then want to go ahead and say the square root of 4 is 2. So those are the quick, short, easy ones. Old rules will apply. We just divide them normally. But then we get to number 3. Here's our issue now. There's nothing we can do to simplify this in the sense that square root of 7 is as reduced as that 7 can get. So what we talked about at the top, we can't divide by an irrational number. We cannot divide by that root 7. So what we are going to do, and we're basing this off the idea, let's say I gave you 4 and I multiply by 1. I think we would all agree we still get a 4. We don't change anything by multiplying by a 1. So let's say I took 5 and I multiply that by a 1. Don't I still get 5? So multiplying by a 1 doesn't change the value of the problem. So don't write this down, because this isn't exactly what we're going to do. But if I multiply by a 1, wouldn't that give me the exact same value that I started with? Like, we wouldn't change anything. But instead of doing it as a 1, the way we are going to write this is as a fraction. And then notice what we have in our denominator here is a root 7. What I'm going to multiply by is a root 7 divided by a root 7. So a couple things now. One last quick example. Don't we all agree that if I take a number and divide it by itself, so 5 divided by 5, doesn't that really just equal a 1? So isn't a root 7 divided by a root 7 really just a 1? It's just a different way of writing it. What that's now going to allow us to do, now let's use what we did on Friday. We're going to go ahead and multiply. So there's a 1 out in front of this. So the terms out in front, the 3 and the 1 that are not underneath the radical, those can get multiplied together. So 3 times 1 is a 3. And then that square root of 7, there is no other square root for that to get multiplied by. So that would just be left as a root 7. That's the new numerator. If you look at your two terms in our denominator, notice how they're both underneath the square root. That means we can go ahead and do a 7 times a 7 and get 49. But since both of those terms are underneath the radical, that means that 49 better stay underneath the radical. And then now you're all saying, all right, well, there's still a square root in our denominator, and our whole goal is for there not to be a square root in the denominator. But we now know in our denominator that the square root of 49 is a 7. Can we now see that we don't have a square root any longer in our denominator? All right, and that's our goal. So this here is our final answer, okay? Yeah, because think about why we could have it in the numerator. Think about that square root of 2 problem that I gave you. The square root of 2, I don't know it past these first few, but if it's in the numerator, what that means I can now do, I could actually now go ahead and say, I can divide this by a 2. I can actually do that. I mean, it's going to go on forever, but I can actually do 2 goes into 1.4, 0.7, and then I would do multiply by the 0.4. I can go through this process now. It's the number that I'm using to divide is the one that has to be a finite number, an actual solid ending number. So in the numerator, we're good. Denominator, we're bad. All right. Yep. All right, so number 4. So here's our issue. We first want to look, can I divide these? They're both underneath square roots. So if a 7 went evenly into a 5, we would just divide them. Okay, but obviously it doesn't. That's a completely reduced fraction. So then our issue becomes, we cannot have this in our denominator. So what we're going to do, we're effectively multiplying by a 1, but we don't use the number 1. We use, notice what our denominator was. That denominator divided by itself is a 1, but it's going to allow us to rewrite this a little bit. Now in our numerator, so if you look at your numerator, notice how they're both underneath a square root symbol. So now I can go ahead and do 5 times 7 and get a 35, as long as it remains underneath the square root symbol. And then in my denominator now, these are both underneath a square root, so we can multiply to get that 49, but we need to leave that underneath the square root symbol. So in our denominator, we're good, because we no longer have a square root in the denominator. It turns into a 7. The numerator, you may sometimes have to simplify that, but a 35, the only way we can get that is with a 7 and a 5. So there's really no way to break that down any further. So then that ends up being our final answer. Okay.
Quick question.
Yeah, go ahead, Kim.
So both of them are square root. Why can't we use the numerator?
Why can't you what?
Why can't we use the numerator? Why can't we use the square root of 5? Why can't we
Oh, okay. Let me show you. So let me write the answer to this off to the right. So this would be a root 35 over 7. That's what we said that answer was. So let's say I took a root 5, divided it by a root 7. We could. There's nothing wrong with this, because aren't we still multiplying by a 1? Isn't this really still just a 1? So that's not wrong. We're not changing the value of the problem, which is important. But let's see how this product would work out. So my numerator, I can multiply those together to get 25. And then it has to stay underneath the square root symbol. And then if I look at my two terms in the denominator, those will multiply to be a 35, but they have to stay underneath that square root. So we now get a numerator of 5 and a denominator of the square root of 35. So the values are the same. So if you threw this into your calculator and you threw the original problem into your calculator, it'll give you the exact same decimal value. But if we look right here, don't we still have a square root in the denominator? Yeah. So we're trying to get rid of the denominator square root, not the numerator square root. So if we did what you did, didn't we get rid of the square root in the numerator? And that's okay, but it's not what we're trying to do so that we could ultimately do long division and be able to divide that number. Okay? So it's always your denominator.
Okay, thank you.
Yep. All right, so this next one, notice how the square root is over all of them. So let's split this up. It just means each of them is being divided by that square root or being used to find the square root. Let's do one more together, and then I'll have you try number 6. So if you now look at what our denominator is. It's a root 2. So what we're going to be multiplying by is a root 2 divided by a root 2. In the numerator, they're both square roots, so those can get multiplied to give us a 10, but the radical better still be there. In your denominator, those can be multiplied to give you a 4, but it should be the square root of 4. The square root of 10, there's nothing we can do with that. We don't have the perfect square hiding underneath there, but the square root of 4 is a 2, and we no longer have that denominator. That's the square root. Actually, let's do one more together, and then I'll turn the next one over to you. At least tell me what you think you're going to multiply by. See if you're understanding that part. We don't want that root 6 in the denominator. So at least throw down what you think we're going to have to be multiplying by. Make sure we have that part out. And then this one has just an extra step at the end. It's not necessarily hard, but we'll do it together. All right. So since currently we have that root 6 in our denominator, if we want to get rid of that, that's what we want to be using to multiply by. So to turn that into a 1, we do a root 6 over a root 6. So now in the numerator, notice now the difference with these. We are multiplying these together. One of them is underneath the radical, one of them is not. So what we cannot do, don't give me any version of 48 over here, or a root 48. We cannot multiply the 6 and the 8 together because one is a radical, one is not. So all we can really do is write this as 8 times that root 6. Those cannot be put together as any version of a 48. In our denominator, though, they are both radicals, so we can multiply those together to get a 36, but the radical would still be there, at least initially, because then we now get an 8 root 6 in the numerator. We now know the square root of 36 is 6. The difference between this one and the previous couple, so look at this answer here. The reason I couldn't do anything with that, the 2 is not a radical, the 10 is a radical. So I couldn't, don't be tempted to like say, yeah, maybe this is a root 5 because 2 goes into 10 5 times. We can't do that. This is a radical, this one is not. So there's no version of 5 we can come up with here. When we come over to this problem though, notice how the 6 in the denominator and the 8 in the numerator, those are not underneath radicals. We can then go ahead and reduce those two guys because those are non-radical terms. So when we think what number goes into both an 8 and a 6, think GCF here, we talked about a little bit recently, that's 2. So each of these numbers I can reduce by a 2, turning this into a 4 and this into a 3. So that my final answer is now a 4/3, and then the root 6 would still be there. But we can only do that if they're both non-perfect square roots. Okay. All right, these are our last 3. Okay, good. You know what? I'm going to leave you about 3 or 4 minutes. Try these. See if you can do 7. There's no new thing going to happen in 7, 8, and 9 that we haven't done in the first 6. These are the last 3 that we need to get through. So just take 4 or 5 minutes, see if we can get through those 3 problems. Back to like this here, let's get square 4. No square 100. Yeah, so the next step, we know what it is. So we write it, you get out of here. And here, going to square 1.1, step, we know, should be square. So up here, looking at any over the 6, we can actually reduce these because they're not underneath the graph. So we look for a J-grade contact. Move this down just a little bit here. And over, apparently. See how the 8 over the 6. 2 goes into both of those. So we reduce both of those by 6, and that's what you do for 12 and 10. Okay, let's see if we got the right answers here. Go through these. I think 7 was probably the hardest in terms of having an extra step there to make sure that we reduce it. 9 would be the one that I would hope was the nicest, and then 8 would have been somewhere in between. So let's go in that order. We'll start with number 9 first. It had the least amount of work, where we're dividing by a root 2 in the original problem. So what we wanted to multiply by was the root 2 divided by a root 2. When we do that in the numerator, the 1 and the 2, it's not a big deal right now because it's a 1 and a 2. But technically, those do not get multiplied together. The 1 would have gone out in front, and the root 2 would have remained underneath. divided by. These, however, are both square roots, so those can be multiplied together to give you a 4, and then it's all underneath that square root symbol. So then that 1 root 2 in the numerator, we know what the square root of 4 is. It's a 2, so that's our final answer. If you don't want to put the 1, you don't necessarily need that right there, but that should have been your answer if you got number 9 correct. All right. So 8. Root 11 is our denominator that we don't want, so you're going to do root 11 divided by root 11. In the numerator, they are both now underneath square roots, so we can go ahead and say that's 55, as long as we leave it underneath the square root. And then in our denominator, we would have had the square root of 121. All right, so numerator, there's nothing we can do with a 55. It's a pretty big number, but if you start looking for perfect squares there, you're not going to come up with it. And then, Christian, what did you find out for the 121 there? When did you ultimately make that? Good. And then that just becomes an 11. So there's no longer a square root in our denominator. You can't do anything else to simplify it. That ends up being your final answer. Okay? All right. And then this one to me is probably the most involved. Not that these are terribly involved, but it would have had the most amount of work. Rebecca, what'd you use, Rebecca? Good. So the root 10 is in our denominator, so she said root 10 divided by root 10. And then we just have to look, since the 12 is not underneath the square root, but the 10 is, we just have to write them next to each other as 12 multiplied by root 10. There's no 120s popping up anywhere. In our denominator, though, we would get what, Rebecca? Good. And then the 10s we can multiply because they're both underneath, so we get a root 100. From there, the 12 root 10, there's not much you can do, but then our denominator we know to be a 10. Right, square root of 100 is a 10. So now from here, this needs to be reduced, because if we look at the 12 and the 10, neither one of those underneath that square root, and there is a common factor that would go into both of those. Ella, what would you decide on, Ella?
5.
Okay, so the 2 goes into both?
Oh, yeah.
Yeah, so what you would end up with, if these both are divisible by a 2, then I like your denominator. But what's 12 divided by 2? 6. Good. So the 12 gets reduced down to a 6. The 10 would have been reduced down to a 5. All right, that should be our final answer. 6 root 10, and then divided by a 5. All right. All right. Pretty good here. Hopefully at home we were able to get through those without a major problem. That's pretty much it. Okay, really, really common thing that you're going to have to do over the next however many years of your math careers is when we're dividing by radical, having to rationalize that. We never really want to leave one of those in your denominator. Okay? All right, so with that, actually have a little time today. That's rare. So just a quick reminder, this is the one that's due tonight. And then you should now, when I do this, you should be able to see this one that's going to be due tomorrow. So again, if you don't have the packet yet, if you just click on the assignment, I did, just give it a minute to open. The assignment is right here, so you can just print this or just look on the screen. If you have the packet, then it is pages, I think it's 2 pages. Okay. Yeah, this page here. 11 through 12. All right, so this is page 11 through 12 in your packet. Actually, you know what? Let's do this since we have a little time. Let's do page 11 through 12. Let me not get rid of that. I'm going to have you do 1 through... No, I want you to try them on your own. We'll do 1 through 10. 1 through 10. So if you have the packet, it's pages 11 and 12. If you need the assignment, just go to Canvas and you can find the problems and the document on your Canvas page. Okay?
You don't want us to do number 11?
No, that's okay. No, go ahead and I want you to complete the square. I want to see if you remember all of that. This is what we learned for the day. Just show that you can do those for now. Okay, and then try number 10. See if you remember how to do number 10. All right?
All right.
Okay. With that, we're done. So we can let you guys go a little bit early here. Let me stop recording. If you have any questions, let me know. You can stick around. Just make sure you get that